Hi, it is the Science Chef again. In this video, we'll be learning about the definitions and types of salts. Go nowhere and we'll be right back after this timeout. A salt is a substance formed when all or part of the hydrogen ions in an acid are completely replaced by metallic and ammonium salts. It can also be defined as the product or one of the products of the reaction between acids and bases. To learn more about the definitions and properties of acids and bases, check the link in the description. Examples of salts and their corresponding acids are sodium chloride from hydrochloric acid, potassium nitrate from nitric acid, copper 2 sulfate from sulfuric acid, ammonium carbonate from carbonic acid, magnesium sulfate from sulfuric acid, sodium ethanoate from ethanoic acid, and so on. From my examples, you can see that the metallic and ammonium ions in the salts, colored blue, replace the replaceable hydrogen ions in the acids. And also, salt in chemistry goes beyond sodium chloride, the common salts you know. Salts can be classified based on their composition and solubility. Based on composition, there are 5 types of salts, namely normal salts, acid salts and not acidic salts, basic salts, double salts, and complex salts. Whereas based on solubility, there are only 2 types of salts, soluble and insoluble salts. Note that the classification of salts based on their composition is more generally used than that based on their solubility when talking about types of salts. So for the purpose of this lesson, our focus shall be on the former than the latter. A normal salt is formed when an acid is completely neutralized by a base and vice versa. In these salts, there are no replaceable hydrogen ions as they have all been replaced by metallic or ammonium ions from the base. Examples of normal salts are sodium chloride, potassium sulfate, magnesium nitrate, sodium carbonate, ammonium phosphate, etc. An acid salt is formed when there is an insufficient supply of the base to completely neutralize the acid. In these salts, not all the replaceable hydrogen ions are replaced by the metallic or ammonium ions, which accounts for the hydrogen in their names. Acid salts are formed by dibasic or tribasic acids and never monobasic acids. Examples of acid salts are sodium hydrogen carbonate, potassium hydrogen sulfate, sodium hydrogen phosphate, sodium dihydrogen phosphate, etc. A basic salt is formed when there is an insufficient supply of the acid to completely neutralize the base. In these salts, not all the replaceable hydroxide ions in the alkali are replaced by the negative acid radicals. Basic salts are formed by bases that have more than 1 mole of hydroxide ions in their molecules, such as the hydroxides of group 2 and 3 and transition metals. Examples of basic salts are magnesium hydroxide nitrate, zinc hydroxide chloride, bismuth 3 dihydroxide nitrate, etc. A double salt is a salt that ionizes in water to produce 3 different ions when dissolved in water, 2 cations and 1 anion. They are obtained by dissolving and crystallizing a mixture of 2 sulfate salts in which one of them has a univalent cation and the other a trivalent cation. They have the general formula X plus 1 Y plus 3 SO42, where X plus 1 is a univalent cation and Y plus 3 is a trivalent cation. Examples of double salts are aluminum potassium tetrahydrosulfate 6-dodecahydrate, also called potash alum, chromium potassium tetrahydrosulfate 6-dodecahydrate, also known as chrome alum, ammonium iron 2 tetrahydrosulfate 6, also known as Morse salt. Complex salts are salts that contain complex ions. These complex ions can either be positive or negative. Examples of complex salts are potassium hexacyanoferrate 2, potassium hexacyanoferrate 3, sodium tetrahydroxyzincate 2, tetraamine copper 2 sulfate monohydrate. Let's now learn in details how each of these salts is formed, starting with normal salts. Sodium chloride is formed from the reaction between hydrochloric acid and sodium hydroxide. Potassium sulfate is a product of the complete neutralization of sulfuric acid by potassium hydroxide. Magnesium nitrate is formed from the complete neutralization of magnesium hydroxide by nitric acid. Sodium carbonate is a product of the complete neutralization of carbonic acid by sodium hydroxide, while ammonium phosphate is produced from the complete neutralization reaction between phosphoric acid and aqueous ammonia. Next is acid salts. Sodium hydrogen carbonate is the product of the incomplete neutralization of carbonic acid by sodium hydroxide. Being a dibasic acid, 2 moles of sodium hydroxide solution will be required to completely neutralize 1 mole of the acid. But when 1 mole of the base is available, it leads to the formation of an acid salt. Similarly, potassium hydrogen sulfate is formed from the incomplete neutralization of sulfuric acid by potassium hydroxide. Normally, 2 moles of the alkali will be required to completely neutralize the acid, given that sulfuric acid is dibasic. Since only 1 mole of the base is available to react with the acid, then an acid salt is produced. Sodium hydrogen phosphate and sodium dihydrogen phosphate are formed when 2 moles and 1 mole respectively of sodium hydroxide react with 1 mole of phosphoric acid. For the complete neutralization of the tribasic acid, 3 moles of sodium hydroxide will be required. Next is basic salts. Magnesium hydroxide nitrate is formed when nitric acid is not enough to completely neutralize magnesium hydroxide, as seen in the equations of reaction. Zinc hydroxide chloride is a product of the incomplete neutralization of zinc hydroxide by hydrochloric acid. While 2 moles of the acid are required to completely neutralize 1 mole of the base, 1 mole of the acid will only lead to the formation of a basic salt, as shown in the equations of reaction. Bismuth 3 dihydroxide nitrate is formed when nitric acid is insufficient to completely react with bismuth 3 hydroxide. For a mole of bismuth 3 hydroxide to be completely neutralized, we will require 3 moles of the acid. But with 2 or less moles of the acid, a basic salt will be formed. Let's look at double salt. Potash alum is formed by dissolving, cooling, and crystallizing a mixture of hydrated potassium and aluminum sulfates, and contains potassium, aluminum, and sulfate ions in solution. The potassium and aluminum sulfates have similar solubilities and hence crystallize out of solution at the same time as a single salt when allowed to cool. Similarly, chrome alum is produced when a mixture of hydrated potassium and chromium sulfate salts are dissolved, cooled, and crystallized as a single salt. It contains potassium, chromium 3, and sulfate ions in solution. While more salt is made from the dissolution, cooling, and crystallization of a mixture of ammonium sulfate and hydrated iron 2 sulfate, and contains the ammonium, iron 2, and sulfate ions in solution. Let's now look at complex salts. Potassium hexacyanoferrate 2 is made from a combination of hydrogen cyanide, iron 2 chloride, and calcium hydroxide, which forms calcium hexacyanoferrate 2. This solution is then treated with potassium salts to precipitate the mixed calcium-potassium salt called calcium-potassium hexacyanoferrate 2, which in turn is treated with potassium carbonate to give the tetra-potassium salt. Potassium hexacyanoferrate 3 is prepared by bubbling chlorine gas into a solution of potassium hexacyanoferrate 2. Potassium hexacyanoferrate 3 separates out from the solution. Sodium tetrahydroxyzincate 2 is obtained by dissolving zinc, zinc oxide, or zinc hydroxide in excess sodium hydroxide solution. Hydrogen gas is evolved when zinc is used. And finally, Tetramine copper 2 sulfate is prepared by adding concentrated solution of ammonia to a saturated aqueous solution of copper 2 sulfate pentahydrate, followed by precipitation of the product with ethanol or propan-2-ol. In our next tutorial, we'll be looking at the preparation of salts. Subscribe to our channel and turn on your notification bell to get notified when we publish the video. Remain on top until I see you when I'll see you.